All right, lesson 12.3 deals with comparing populations. We're going to go through this explore activity first that uses dot plots to compare populations. You can compare two populations by taking a random sample of each population and comparing the samples using dot plots. So we're going to look at a test prep company that gives its students a pre-test before the course and a post-test after the course. The test prep company picks a random sample of 10 students from each testing session. So the first thing I see here is that I have all my data. Okay, and it's not in order. I'm doing a dot plot, so it's okay. I'm not going to reorder it before I start, but sometimes it benefits you to reorder it. But I'm not going to need to do that for this one. So I'm just going to put a dot above every data value that it matches. So 520, and then I always like to cross it off my list so that I don't use it twice by accident. 510, 550, 580, 600, 480, 480, 460, 460, and 640. You want to make sure when you're making your dot plots that it's easy to look at. So I shouldn't have 3 dots be the same height as 1 dot. Okay, so I kept them all in a pretty good, it wasn't perfect, but it's a pretty good line. You can tell those are all the same. And then I have 2 that have 2 of them, and none are that same height because all the rest are just 1. So you want to keep it pretty evenly scaled. Okay, now my post-test scores, 510, 480, 510, 610, 590, 670, 550, 560, 600, and 610. And again, they're all pretty even. All right, now it says compare the dot plots. The plots have similar center or spread. Well, in order to figure that out, I've got to figure out what the center is and what the spread is. So to find the center, I need to find the median of both of them. To find the spread, I need to find the range of both of them. So the median of both of them, 1, 2, 1, 2, 1, 1, 1, 1. I have these two, and the data is right between 510 and 520, so the median is 515. The median for this one, 480, this one, 1, 2, 1, 2, 1, 1, are these 2 points between 560 and 590, so that would be 575. The range is going to be 640 minus 460, and that makes 180. And the range here is going to be 670 minus 480, which is going to be 190. All right, well, if I look at my two answers, 180 and 190 are a lot closer together than 515 and 575. So the spread is similar, but the post-test values are shifted to the right. Right, it starts at 480, that starts at 460, it ends at 670, and that ends at 640. So what can you infer about the population by comparing the dot plot? Well, if the post-test is shifted to the right, that means the post-test has better results than the pretest. Okay, so let's move on to box plots. Okay, in the last module we looked at box plots, but we never had to make them. So right here we're going to learn how to make them. All right, the first thing I want to do when I'm making a box plot is to order my data. I need to get my data in order from least to greatest. So I need to look at these numbers, and I'm going to have to reorder them, and I'm going to make sure I'm going to have to keep them in order and keep track. So if I look through here, 3 is the smallest number I see. Then I have a 4. Then I have a 5. Then I have a 6. Then I have 2 7s. Then I have 3 8s. Then I have an 18. Okay, now when I reorder my boys, I have a 7, 1, 2, 3 9s, 2 10s, a 12, a 15, and 2 18s. And you want to make sure 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 7, 8, 9, 10. Good. I know I have 10 and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You always want to double check your count. Order my data from least to greatest. Double check your totals so that you don't make mistakes or accidentally forget a number, and kind of cross them out as you go. That will help you from making mistakes. Okay, so now I have my numbers in order. All right, well, let's first start with the points that we know that are the 2 easiest ones. So you need to then identify the min and the max. Okay, so for girls, this is the girls, and this is my girls' data. My min is 3, 1, 2, 3. So I'm going to put a dot right there to represent 3. And my max is 18, and that's where that dot goes. So those are the points on my whiskers. Okay. Then I'm going to identify the mean. I'm sorry, the median. So I'm going to count 1, 1, 2, 2, 3, 3, 4, 4. And since they're both 7, my median is going to be 7. It's going to be right there in the middle, 7. Okay, well, since my median splits this data in half right here, now I've got to find my interquartile ranges. So I'm looking at this half, the lower half now, and the upper half now. So now I've got to find the median of this data, which is 1, 2, 1, 2, 5. So my line goes right here on the 5. And up here, there's again 5 numbers, so my median is going to be right here. That's going to be 8. 7, 8, so that goes there, and then I just have to connect my points. So we talked a lot about this a little bit, so hopefully it makes a little more sense that this line right here for the lower half of the interquartile range is actually the median of the lower half of the data. And this line right here for the upper quartile range is the median for the upper data. And if you have 2 numbers, instead of just taking that one out, you actually draw a line through the middle of them, and that's all your lower data and that's all your upper data. Okay, so that's how you would draw that box and whisker plot. Okay, now let's do the same thing for the boys. I already have all my numbers. Okay, so I ordered my data, I double checked it. Now I need to identify the min and the max. Well, that's pretty easy. That's 7 and 18. All right, then I have my 1, 2, 3, 4, 1, 2, 3, 4. And then my 2 numbers that are stuck in the middle together, I'm going to draw a line right through them. They're both 10, so my median is 10. The median of my lower set of data is 9. And the median for my upper set of data is 15. So those are my interquartile boxes. And I can connect my whiskers. And I have my two box and whisker plots. Okay, compare your plots. The plot for boys has a lesser range, has a lesser or greater range, but a lesser or greater inner quartile. Well, let's look at the boys. This is the boys. So is the range here smaller or larger? Well, it's shorter right here. It's 18 minus 7, and this is 18 minus 3, so that's 15, and this is 11. So the boys has a lesser range, but a greater inner quartile range. That goes from 9 to 15, so that's 6. And that's 5 to 8. The middle 50% of caps was spread out less, so this is the middle 50%. The IQR equals the middle 50% of the data. So who has the less spread IQR? That would be the girls. All right, let's flip this over. So now we want to reflect. What can you infer about the population by comparing the box plots for the samples? Okay, well, if you look at this, the boys tend to own more hats, right? Because most of their numbers are more than the girls. So you can say the boys tend to own more hats. Okay, let's see, what else can we infer? For the girls, about 50% own more than 7 hats, or have 7 hats or more, because this is my 50% mark, and there's about half of my data that's above that. So about half of the girls own more than 7 hats, yet all the boys own 7 or more hats. Okay, so that's a good comparison there, because the bottom, my min value is 7 for that. So that's a good thing to compare. You could also say that the max value is the same, but the girls is an outlier. So there's happens to be one random girl that really likes to wear hats, and she's an outlier. It's not what's true about most of the data. Okay? All right. So now we want to use statistical measures to compare populations. That just means you're looking at the mean, median, mode, and range. All right, so you can use the means and ranges of 2 random samples to compare the populations that the random samples represent. Paula and Daniel wanted to determine the average word length in 2 books. They took a random sample of 12 words in each and counted the length of each word from each book. All right, well, the first thing I want to do is calculate the mean. So I have to take the total divided by the number of books. So what they're doing here is just adding up the total. So 375 plus 2 plus 4 plus 3 plus 1 plus 6 plus 4 plus 8 plus 2 plus 3. Okay? And that's 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12. 12 is my total. When I add up all those numbers, I get 48. I take 48 divided by 12, that should be 4. So that the mean for book 1 is 4 letters long. All right, the range for book 1, well, I've got to come through here and identify, kind of crossed out everything, so I'm going to look down here. 1 is the smallest number I see. See, I have a 7, I have an 8. 8 was the highest number I see, so the range is 7. All right, now let's look at book 2. I have 5 plus 4 plus 3 plus 6 plus 4 plus 5 plus 5 plus 2 plus 3 plus 4 plus 2 plus 5. Well, guess what? When I add all those up, I also get 48. Again, there are 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 48 divided by 12 is 4. So the mean for book 2 is also 4 letters long. Well, if I want to find the range, I'm going to look through here. My highest one, it looks like, is 6. My lowest one, there's a 2, is a 2. So the range for this is only 4. So you can infer from the mean of each population that the overall average word length for book 1 is less than, same as, or greater than. Overall average, I realize that they're both 4, so that means it would be the same as the average word length for book 2. You can infer from the range, so now we're looking at the ranges of each population, that the length of the words in book 1 varies. Well, if the range is higher, then this one has more vary, and this has less vary, or varies less. I'm not sure that makes sense, but this one has less variation because it's only a range of 4. Okay, what are the populations from which the samples are taken? Okay, well, what did they take? What are the populations from which the samples are taken? Well, the words in book 1 and the words in book 2. So for this, it's all the words in book 1, and for the second one, it would be all the words in book 2. All right, those are your notes for tonight. I will see you tomorrow. Have a good evening.